Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. How's everyone doing today? Today we're going to take a quick look at what I have on my bench for testing circuits, figuring out logic chips and different things, whatnot, that I always keep on my bench. I keep this little container. It's Elgo. I believe it came with some sensors or something, but it's a nice little container. And for whatever I do on the bench, I always have it here, and it always tends to have what I need in it. So open it up. I have a quick reference to tell me what the numbers on a trim pot is, because I have some trim pots over here. But I have a assortment of capacitors, some buttons, way too many buttons, diodes, tilt switches, LDRs, RBG LEDs, and then I have red LEDs that are bent in a way that the positive rail is short, but I put a little red wire on it, and then I have some, and then these are bent, so the negative rail is the bent one, and I do put some black on there, and I'll show you that on a breadboard later. I just started doing that. And then I have some LEDs with the resistors already soldered to them. Various resistors, more LEDs, transistors and MOSFETs are over here. Ceramic capacitors, my resistors, these are all 220 ohms over here. This is a, as I use a resistor and I'm done with it, I throw it in here, and then I end up digging through there, one of these two piles, to see if I have the resistor I need. If not, I'll just grab another one. I have an assortment of common resistors down here. Common resistors, I have 220 ohm. What do I got here? I got 10 ohm. That's not very common, but, and then I have 100 ohm, 330, 1K. Not much left on the 10K strips. I gotta add some more 10K, and then another 330, and then 2K, and then I got a 5.1K and 1 megohm resistors. Looks tucked in there, and this is just a strip I got from a kit. It's got a bunch of different values on there, and normally when it gets this long, I cut off the excess stuff. I'll do that now. But it just has a different value of resistors on it. And then I just have to check my color code. And I keep my color code card right here, because my memory, with the brain damage I suffered, my memory's not that great, so I keep a color code card just right over here off to the side, so I can quickly reference what I need to what I have. So that's resistors. An assortment of LEDs. I have some buzzers, some very bad switches, potentiometers, some segment screens for various projects, some of these. I even got some OLEDs in here. I keep the OLEDs in here because it's safer than keeping them anywhere else. And then I have some different 555 chips and some shift registers, opto isolator, and then I have these good buttons I just received that are very good, and you can put different color caps on them. You can probably see those in videos. Got a Rotary encoder because I've been messing around with those. And then if I start messing around with something that I'm going to be messing around with, I will put it in this little kit. So that's my little go-to kit. That's that. And then for building my circuits, I have two large breadboards. I have this one is a project I'm working on, and you can see the negative bent LEDs have the little black wire on them, and the positive bent ones have the red wire on them. This is just a circuit I'm trying to design, trying to use a rotary encoder to shift ones and zeros into a shift register. It's a little glitchy. I'm working on it. I got to put it back on the scope and see what's going on. And then that's that board. Then I have this board right here. This is the board I use for my logic series. I have a 555 timer clock up here in astable mode. I have a monostable mode, so I can send just a clock pulse pushing the button, and then I do all my logic for the videos here. Currently, I believe it's got an LS8 and an LSO2. I believe I'm doing some kind of gate there. It's an AND gate and a NOR gate, so I must have been making an SR latch with enable. So this is an SR latch with enable. So I was making a video on that. You'll see that on the channel probably soon, maybe before or after this. And then, this is my main go-to board. I'm not real happy with the spacing on this. The spacing on this seems to match up with my breadboard wires a little bit better than this one. But I do like this one the way I have it set up with the power supply, the incoming, and I just plug in my banana jacks and then turn on my power supply and I have power. So I plan on getting a new power supply, a singlet, triple output power supply, and then I'll be reconfiguring my designs. And then for breadboard wire, I have this jumper kit that is actually a combination of many different kits. I go through a lot of these jumper wires, so I buy these on Amazon for $6 or $7. It comes with 840 different jumper wires, and then I constantly restock what goes bad and that stuff. And this one is all the long ones, because the long ones are used so rarely. So I use this one to cut wires to make them fit neatly on the breadboard, and I also store the custom jumper wires I make with this roll of wire here. I'm not sure what gauge this is because it doesn't tell you, but it's thicker than a jumper wire and it's more durable, and it's got a nicer PVC sleeve that's soft. So this makes good jumper wires, and I can get red and black for my power and ground. It's the main reason I use it. I normally like to use white for a clock signal and things like that, so it's easy to distinguish on the board. So that's those three containers, and then I have my power supply that's off screen. I moved my oscilloscope as I plan on getting some new equipment for long-term projects with the Arduino. As long as it's not too complex, I use this board here. It has an Arduino Uno and a Mega, and I can hook it directly to this power supply, plug in a jack down here, and then I can power both the Arduino and the board. And then here is my traffic light program that is semi-working. So, and then I can just do little builds on here, and I have everything I need. If I need multiple outputs or inputs for digital pins, I have the Mega for extra input. And this is normally more for long-term projects with the Arduino. It's small, I can just sit it out of the way and store it and then get back to it. And this one is a little neat. This is just a Arduino board, and then this is what I do little teaching things on, like PWM or how potentiometers work and things like that, because I can put one of these shields on there like this, and then I have a little breadboard. I got a potentiometer and a LED, and then I can just use this for demo purposes, just to show things off. So it's very small, it tucks out of the way, and then if I want to, I can pre-build circuits on different prototyping boards and just swap them in and out and just change the code. So that is that. And then I have my three types of meters. I have my Lumni graphical meter. This is nice because the display shows up very well on the camera. Not my favorite meter. It is my more expensive meter. It's not my favorite, but it does show up really well on camera, and it does do the basic stuff. I'm not a big fan of all the extra graphical stuff and all the extra stuff it does, but for a basic meter stuff, it works great, and it does show up on the screen very well. And then my favorite meter, I've tested a lot of meters, is this Astro AI. They make a lot of different models. This is the model I like. It's got a big screen, but as you can see, it shows up, but it's not as even with yeah, see, I don't, there's supposed to be a backlight, and it's yeah, see, I can't even get the backlight on. But this is what this is one of my main meters. I have one set up over here for this view. I have one in the corner there, and I have, you know, my leads within reach that I could just turn it on and measure stuff and show you guys the output. So these are nice meters. I like to have two. If I buy meters, I like to have two, because their accuracy and their function of how they read things are going to be roughly the same, because these two might use different circuitry to measure their circuits, and if I'm measuring voltage drops off multiple components at one time, I want to use two of the same meter. And if I'm measuring like different resistances at one time, comparing, I would like to use the same meter. So if an error occurs, I believe, you know, it's going to be about the same on the other one. So I have 2 meters, 2 of each. If I had it to do over again, I would buy 4 of the Astro AIs to give me 4 meters, but that's that. Now, for current, I will use those meters for current, but current is a weird thing with meters, because if you mess up setting up your meter, which I'm not the best at setting up a meter, and I'll show you on this Astro AI. If you look here, it has your common and your input for everything but amps. And then it has an input for microamps and milliamps. So, you know, as long as you're over here in microamps and milliamps, you're good to go to use this port. But if you go to 1 amp, you have to be in this 10 amp port. So if you go over here, you need to be in this 10 amp port. And if you're measuring something in milliamps and it's like 990 milliamps, and then, well, it won't, this fuse is maxed at 400 milliamps. So if you thinking, oh, I'm measuring milliamps and it's like 425, you're going to blow the fuse in your meter if you're using this setting. And then there's a huge gap between 400 and the 1 amp reading on the 10 amp. So it's issued, and the fuses, when they blow, a lot of times they're hard to find, they're expensive, and I just, ever since I was a kid in high school, I was always weird about measuring amperage with a higher priced meter. Unless I know that it's going to be 10 or 15 milliamps, I won't use a higher end meter. If I'm unsure of the amperage, I'll use one of these cheapy $3 meters. These are unfused. So the worst thing that happens is you blow up your $3 meter and you buy another one. I mean, this meter's cheaper than a fuse for the nicer meters. It's not exactly as accurate, but I can get a rough estimate of what the amperage is and then switch to a nicer meter. And I also have 2 of these. These are cheap. A lot of times, after I bought these 2, I found that you can buy these in bulk of 6, which is pretty cool. I mean, they're not that great of a meter, but if you, I've never blown a meter measuring amperage, but it's a fear I have. It's just, It's one of the quirks about me. I just have this fear of blowing a meter with an amps. And I don't ever measure anything high amperage. I work in low amperage, low DC voltage, like 5 volts, but I always have that fear that I'm going to blow a fuse in a meter. It's weird. So, you know, one time I'm going to be working on like a large series or parallel circuit of LEDs, and it's going to draw like 200 milliamps and blow my fuse. So, that wouldn't be a thing, but just this is basically your milliamps plug into this port and your amps plug into this port. This is fused at 500 milliamps, but again, it's a $3 meter, and I believe I have fuses I could just replace these fuses with. But this is nice because you can just, you know, you can come down to 200 milliamps, 20 milliamps. I start at 200, and then I hook up my circuit in series, and then I can adjust it, you know, based on the amperage I got. Like I said, it's not the most accurate and highly accurate in the world, but these are nice for quick measuring current in series. Like I said, I have 2 of these and I keep the leads on these at all times. And these are cheap leads. I just wrap them around, and then I keep them stored over here. So I have 2 of these. The other one's tucked back in there. For leads, I prefer interchangeable tips on my leads. Like this set of leads is going to be for my desktop meter. Then I get that and see how they work on this. So you just plug in plug it in like that, and then you have, you know, these fine little tips, but you can also pull these off and put on, say, these alligator clips that I have sitting out. So I can put on alligator clips, you know, if I want that. And then there is a whole range of needle inserts to change the diameter for measuring breadboards. These terminal clamp type of circuits. Here's, you know, ones you can put in to extend pieces to make it longer. There's, you know, long, thin, skinny, pointy ones. There's just a whole, you know, ones that plug into banana jacks. So that is, there's a large range. You get those. You get a whole set for a decent set. Like this set right here. This is 28 cap 3 at 1000 volts. These are about $35. And then there's sets that are a little bit cheaper. No, these are cat 3. I guess they're all cat 3. But they come with cheaper probes, like these probes here. These are another set of probes that they come with if you get the cheaper version. They still say cat 3, but these seem to be softer on the feel, so it's worth a couple bucks extra to get the nicer leads. And with the multi-tips you can put on, it's very nice. And you can find them with one side at a right angle and one side straight on. The both sides straight, that is a little bit more difficult to find, and I only have the one set, and I plan on using these for the desktop meter, benchtop meter, and I just will continue to use these for my meters. You could plug them in reverse and use this part for the measuring and, you know, hold it like this. Never thought of that. I could try doing that. So I like those leads. And then also, what's nice about, you know, that set, it comes with, you can also get these banana jacks to banana jacks, and they're actually stacking. But I had to take off the sleeve on one end for it to plug into my power supply, so this plugs into my power supply. And now I can plug in, from my power supply, I can plug in these adapters, so I've got banana jacks in there now because that's what I'm using. but I could also plug in alligator clips to power circuits, or I could plug in like these to, power individual, things like LEDs, or, just put power on a certain thing and take a measurement reading off of it. So these are the banana clips I use. These come in a pack of 6. You get red, black, green, blue, and yellow. I have yet to use the other colors, but if I do get a 2-channel power supply, I will have a use for the other colors for the other channel. So that hook is supposed to hold those. So that is my multimeter leads, and then I keep a chip puller over here. I keep 2 ceramic screwdrivers, 2 flatheads. Normally one is a pointed one, but I don't know where that one is. And then I keep 2 fiberglass tweezers that are non-conductive. So, and then I have my pliers. For your scale modelers, these Tamiya mini bending pliers are fantastic for bending leads on resistors, capacitors, and whatnot, and also pulling out wires from the breadboard. These are fantastic for that, so I'm repurposing those. Then for pliers and cutters, I prefer Xuron. I have a wide range set of Xuron tools. I just have 3 here right now. I have on a magnetic strip, which I don't think is a good idea, but I do it anyways, for the purpose that it magnetizes the tips, and that could be a problem. But I ran into the problem, but the ease of storing them there outweighs the problems I run into. So this is just regular long nose non-marring pliers, and this is rounded pliers. Use this for bending leads sometimes. So just stick those back up there. Oh, they stick up there loud. So cutters and things like that, and then I have a ruler with the stop on it that I use to measure leads for bending or measuring wires and whatnot, and that just sticks up there too. This is actually general. It's a general tool supply. You can get these on Amazon. I believe I got 5 for like $3. They're very cheap. When I was doing machining and engineering at a company, I used to use these because you can clip them on your pocket, and it's a quick and dirty depth gauge. You can use it to set stops. It's not super accurate, but if you're doing manual milling and stuff, it gets you close enough to where you can just make your measurements in the machining process. So as long as you're square, you can get close and then take your measurements from there. So they're pretty good rulers. I also have some Michitoya ones that are good, but I like that because it has the depth stop on it. So I believe that is it. And then off to my right, I have all my ICs in a couple of storage systems that hold little drawers like this. This one has LEDs. I have these on 2 of these on the left side. One has bigger drawers, and I have 2 small ones, and then I have a medium and a large one on the shelf and table system I showed in another video. And I have my pad, so I can write and draw and show you things on there. And then that is basically it. That is what I use mainly for building electronic circuits. There's a lot of other things you can do. Like my soldering iron is up here on the shelf. I rarely solder until I'm on the final project. Like this project I'm working on here is getting close to getting done. So when this project is finished, I'll be soldering this on a breadboard. I'll be actually, if gets finished and works properly, because I'm having some glitch issues, it's going to be a code crack game, and I'm going to be putting it on a circuit board and putting it in a 3D printed case. But let me just give you an example of this, what I've been working on here, so you at least get something cool. It's kind of an update and whatnot, so let's just power this up. The one thing I don't like about this power supply is once I turn it on, it outputs the power, and sometimes I have it set to 9 volts and sometimes 5 volts, so I have to turn it on and check the power. So here is a shift register with all the lights lit. Here is a rotary encoder with the data and clock pin going through, each one going through their own RC circuit, going into a LS74LS14, which is a hex inverter with a Schmidt trigger, and those outputs are feeding the data and clock inputs to a 74HC595 shift register. The latch pin is pulled high, so I get the outputs, and then everything else is, you know, positive, negative, and the outputs are going to these LEDs here. So those outputs are going to those LEDs there, and in theory, when this works, you set a code like this, say, if I can, so that one and that one. So this dip pit does not fit on this breadboard. I never find ones that fit on the breadboard well. Okay, anyways, when it's soldered to a circuit board, it'll be better. So say this one's lit, you know, and you have everyone lit, and then you're supposed to be able to shift in ones. See, now I can see if I turn it, I can shift in all ones, and I turn it the other way, I can shift in all zeros. But the goal is to turn it and get a 1 and then shift in a 0 and then shift in another 1, but I'm still having some issues with the circuit, the way the output of the rotary encoder, in theory and on the scope, it looks like it should be shifting the data incorrectly, and I will just show you that real quick, what I'm talking about. So let's just go to this right here. So the rotary encoder has a data pin or A and a clock pin, and sometimes it's called B. So the data goes like this when you turn it clockwise. Okay, so it's a 0 here, a 1 here, a 0 here, a 1 here, a 0, a 1, and a 0. And the clock signal going clockwise goes like this. Well, this isn't exact, so for this whole section, 0, 1, 0, 1, 0, 1, 0. So you are sending in data here, so it's a 0 this whole time, but on this clock signal, so when this clock signal goes high, which feeds into the shift register, there's a 1 stored in the data. So data is going high because it's being inverted. Normally it goes low, but it's being inverted. So it should clock a 1, and then on the next cycle, turning clockwise, the data's high, and then clock goes high, so another 1. And then going the other way, you have data. Try to draw this better. And then you have clock comes before. So you have clock going high here, but you have a 0 stored. So going in the opposite direction, you know, this one's going this way. and this one's going this way. So in theory, on this clock pulse, it should be clocking a 0 every time it's turned this way, and this goes high first and this is low. You should be getting a 0, and it works, because if I just keep turning it this way, I can clock all 0s. If I turn it this way, I can clock all 1s. But as soon as I clock all 1s, it clocks all 0s again, turning it, clockwise. So I don't understand why it has to. It seems like it finishes out the 8 bits, and then it's not getting 8 bits in. Like it has to store 8 bits. So I'm thinking it has to do with the latching system. I might need a different type of shift register, because it seems like I have to fill up the storage register, and then it outputs what's in the storage register to the LEDs. So there's an 8-bit stage in here. I need to put 8 bits in the storage register, and then as I add another bit to the 8-bit storage register, the first bit in the storage register is output on the display. So, and what I think is happening after I input the 8 bits, it latches and the storage register is empty. So then as I feed in 1s again, it forces all 0s through. So that's what I believe is happening. I'm not sure. Hey, if you guys know what's going on, please leave a comment down below, because I've been on a bunch of electronic forums trying to explain what I'm doing. A rotary encoder is not designed to do this. I don't even know if this is going to be a working possible thing in the end. But what I'm thinking is I may need to see what is going into the shift register, and then what is being put out on the outputs. But that is going to be difficult, because there's no pins showing me what is on the shift register. So I'm going to probably put a decoder chip to decode what I'm putting in instantly, so I can see what's going in and what's coming out, to see if there is that delay in the shift register. I don't think I have the chip up. Let's see, do I have the chip right here? No, I don't have the chip. Let's see. Let's do a search for the chip. If you guys need data sheets, I go to texasinstruments.com, ti.com, and for all the TTL logic and CMOS logic, I just type in the number and they give me the equivalent part, but they also give me the data sheet. Let's go to this part right here. You see I typed in HC595 and I got the shift register, and then I can click on the data sheet. Let's just make that a little bit bigger. Go this way a little bit, and we'll turn on draw. So here is the shift register, and if we look at it, it contains an 8-bit serial in parallel out shift register that feeds an 8-bit D-type storage register. The storage register has 3 state parallel outputs. Separate clocks are provided for both the shift and storage register. The shift register has direct overriding clear input, serial input, and serial output for cascading. When the output enable input is high, the outputs are in a high impedance state. So both the shift register clock and the storage register clock are positively edge triggered. If both clocks are connected together, the shift register is always 1 pulse ahead of the storage register. So I would assume if I tie, see currently I have the R clock not connected. 12, what do I have connected to 12? Let's see, that's 9, 10, 11. Alright, 12 is connected, and I'm dated 10. So I'm connected to the register clock. The register clock. But I may need to be connected to the storage clock. So the storage clock is pin 11. So what I'm going to do is I'm going to jumper pin 11 to pin 12 and see what happens. Let's see, 9, 10, 11. So I'm going to jumper pin 11 and 12. And we're just going to see here. Jump over here real quick. I could probably do both. What does that do? Oh, yeah, let's do that. So let's do 11 and 12 right here. Let's see. See, this can become a info video and then just me messing around. So I hope that's okay, guys. I didn't know where this video was going to go. Alright, let's turn that back on. Now let's see what happens. So that's shifting all zeros. There's a 1. That's going to shift another 1. Now a 0. So I shifted 2 zeros. So now if I go 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. See, as long as I don't hit it too many times. So there, I got 1, 0, 1, 0, but there's a blind spot. There's a 1-bit blind spot. So, yeah, it seems to be, because of that delayed clock pulse, there's a 1-bit blind spot. But that definitely seemed to solve the problem. Let's make that bigger so you can see that. Well, let's see, made a video, solved my problem. So, say I needed to match that code, and I was able to match that code with this shift register. So now if I want to shift in a 0, I click it one time, and there's my 0. Now, I believe I have another 0 in here. So if I try to shift a 1, I believe I'm going to get a 0. Let's see if that's true. Yeah, I got a 0. Now if I shift another 0, I'll get my 1 out. Okay, so now I have a 0 stored in the register. So now if I want a 1, see, there's my 0. Now I have a 1 stored in the register, and now there's that 1, and I stored a 0. And then there's that 0, and I stored a 1. So now I'm going to store a 0 and a 0. So now I have a 0 stored and a 0 on. And then now I'm going to display that 0, and I'm going to store a 1. So now I have a 1 displayed and a 1 stored. And now I'm going to do a 0, which shows me that 1. And then another 1 does the 0. And then another 0 shows me that 1. So there's a 1-bit hidden bit that is hidden in here before it displays on the next clock pulse. Now, if I read this correctly, so the shift register is always 1 clock pulse ahead of the storage register. And the way that my clock works, I'm only doing 1 pulse at a time. So the clock pulse goes off, clocks my bit into the D-type register, and then the second pulse that comes through, it goes to the register pulse, which displays it. Now, if I could make this, when I click it one time, I get a double pulse. So that's the key. Could I make it to get a double pulse. Or I could do it to where I hook a clock pulse up to the register clock and have a button to where I could store the 8 bits in the D-type register and then clock the register and all 8 puts would be outputted. So I could set up a 555 timer in monostable mode and give me 1 clock pulse to output all 8 bits of data. That's something I'm going to work on. If you guys want to see me turn this 555 timer into an individual clock pulse to work on this more, let me know. I wasn't planning on showing any of this in videos other than, you know, talking about using this as a clock and data input. And it turned into me talking about my tools and going into this whole troubleshooting session. I wish that I could get this to work, but it won't stick in long enough. So let's say I have this. This is 1 on, off. Seriously, guys, it's just, I wonder if I put it in a socket, a rolled pin socket, I wouldn't have these issues. Just the pins are so short and they don't grab. I wonder if they will grab on this board better, because this board is a little better quality than that board. So yeah, see, it grabs on this board because they're a little closer together. So that is interesting. So I may have to switch my design to do logic testing over here and my game system on this because of this section here. So I am going to be done with this video. I hope you guys enjoyed the little setup and what I use, and then this whole little troubleshooting session I went into on that, and hey, I solved the problem. So it's a concept that works. So I'm going to try to set that up in a different way. So that's going to do it for this video, guys. Here is the links to my social media, and if you want to support me on Patreon, help me get that power supply meter and arbitrary waveform generator, you can donate there. It'll help me expand the content I can share with you guys, and we can do all kinds of cool stuff, putting lights in all kinds of aircraft carriers, tanks, all kinds of lights. I'm going to be talking about surface mount chips and how to install them on the landing deck of aircrafts and things like that. You can do it with an Arduino, or you can do it with some discrete IC chips. Going to be talking about that soon. So thanks for watching, guys.